Hi friends, welcome to all. In this video, we are going to solve the packet tracer activity. Determine the DR and BDR. Before coming to this activity, friends, if you like to get any CCNA version 7 online support or any other project support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get these type of technical videos in future, consider subscribing. And don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Back to the activity. Here we can see our addressing table and objectives. In part 1, examine DR and BDR changing roles. Then in part 2, modify OSPF priority and force elections. Scenario. In this activity, we will examine DR and BDR roles and watch the roles change when there is a change in the network. We will then modify the priority to control the roles and force a new election. Finally, we will verify routers are filling the desired roles. Coming to the instructions. Part 1. Examine DR and BDR changing roles. Step 1. Wait until the amber link lights turn green. Yeah, we can see all the lights are in green now. When you first open the file in Packet Tracer, you may notice that the link lights for the switch are amber. These link lights will stay amber for 50 seconds while the HTTP protocol on the switch makes sure that one of the routers is not another switch. Alternatively, you can click fast forward time to bypass this process. Yes, it was. So in the beginning, we have seen all these switches were in amber and now it's in green color. Coming to step 2, verify the current OSPF neighbor states. Use the appropriate command on each router to examine the current DR and BDR. If a router shows full bar DR other, it means that the router is not a DR or a BDR. And here itself they've shown the output for all these show command on each routers RA, RB and RC. Here we can see that RA show IP OSPF neighbor, and we can see this 192.168.31.33. It's a full bar DR, that means this router. RC, then it's a 31.22, it's a full bar BDR, it's here router RB. And here we can see this router 192.168.31.11, that is this router RA is in DR other. We have this question, so which router is the DR? Yeah, we have seen 192.168.31.33 is the DR, that means this router RC. Then which router is the BDR? Here we can see BDR 192.168.31.22 RB router. And what is the OSPF state of router RA? We can see it's address 31.11 and it's a DR other. Just we will verify this in our topology using this show command, show IP OSPF neighbor. So we'll go to RA, enable show IP OSPF neighbor. And here we can see 192.168.31.22, it's BDR, and 31.33 it's a DR. That means RC will be the designated router and RB will be the backup designated router. Now we will go to RB and we can give that same command, enable show IP OSPF neighbor. We can see this is RA and this is RC, and this RA is in DR other, and 31.33 is in designated router. You go to RC, show IP OSPF, so BDR 31.22, also we have a 31.11 DR other. Step 3. Turn on IP OSPF adjacency debugging. You can monitor the DR and BDR election process with the debug command. On RA and RB, enter the following command, that is a debug IP OSPF ADJ, that is a OSPF adjacency event. So we have to give in both routers RA and RB. We will go to RA. Here we can give a debug. We have IP OSPF. Here we can see ADJ OSPF adjacency events. OSPF adjacency events debugging is on. Now we will go to RB. Debug IP OSPF ADJ and OSPF adjacency events debugging is on. Step 4. Disable the gigabit Ethernet 0/0 interface on RC. Okay. Use the shutdown command to disable the link between RC and the switch to cause roles to change. Wait about 30 seconds for the dead timers to expire on RA and RB. According to the debug output, which router was elected DR and which router was elected BDR? We can guess that, right? So according to this topology, RC is the designated router, and RB is the backup designated router. So once this RC goes down, this backup designated router becomes this DC, right? And obviously RA become the backup designated router. Okay, we will verify that. We will go to this RC, then to this interface G0/0, then we will shut down this interface. Okay, here I will go to conft, then we will go to that interface, that is G0/0. Once more I will verify that interface it's correct, and we will give shutdown command. And we get some message here. We can see neighbors 31.22, it's a detached or down. Okay, so just we'll go to this routers RB. Okay, let me come back to this RA. Okay, that's fine. Actually we have to wait 20 to 30 seconds. Yeah, here we get some message. In RA, here we get some message. Let me check that. We can see elect BDR 192.168.31.22 and he become DR 192.168.31.22. Okay. So here we can see DR 192.168.31.22. That means RB become now designated router. Then BDR is 192.168.31.11. That means RA become the BDR. Step 5. Restore the gigabit Ethernet 0/0 interface on RC. Re-enable the link between RC and the switch. Then wait for the new DR BDR elections to occur. Did DR and BDR roles change? Explain. Okay, we will check that. Just I will give a no shutdown here. No shutdown. Obviously not. There won't be any change in DR and BDR. RB will be the DR and RA will be the backup designated router. Sure, one thing we have to keep in mind. Previously, RC was the DR, that is a designated router. So now we shut down and RB become DR and RA become BDR. So once we activated back, he will not become the DR back. So that is not happening in the OSPF. Okay, that's fine. We will verify the DR and the BDR assignments using the show IP OSPF neighbor command on a router RC. So show IP OSPF neighbor. Enable show IP OSPF neighbor, and here we can see 192.168.31.11 is the BDR, that is RA, and the DR is 192.168.31.22. It's RB. They given a note. If the show IP OSPF neighbor command does not return RB as the DR and RA as the BDR, turn off debugging on RA and RB with the undebug all command and retry steps 4 and 5. Yeah, it's working for us. So we will go to step 6. Disable the gigabit Ethernet 0/0 interface on RB. Disable the link between RB and the switch to cause roles to change. Wait about 30 seconds for the hold down timers to expire on RA and RC. Then according to the debug output on RA, which router was elected DR and which router was elected BDR. We will go to this router RB and we will shut down this interface G0/0. conft interface G0/0, and we will shut down this interface, and here we can see the messages. So everything removed and they are electing the new DR and BDR. So we will wait for 30 seconds. Then we will go to this RA, and here we received these messages. DR 192.168.31.11 and BDR is 192.168.31.33. So now DR become this router RA, correct, 31.11, and BDR is 31.33, this router RC. Coming to step 7, restore the gigabit Ethernet 0/0 interface on RB. Re-enable the link between RB and the switch. Wait for the new DR BDR elections to occur. Did DR and BDR roles change? Explain. Okay, just we'll go to RB, and we will give no shut command. After activating this router RB, there will not be any change in DR and BDR. DR will be this RA and BDR will be this RC. We can verify that. We will go to RB and we will verify it. Coming to RB. Okay. And here we will give that command to show IP OSPF neighbor, and we can see 192.168.31.11 still in DR, that means RA, and here we can see 192.168.31.33, it's in BDR, that means this router RC. Use the show IP OSPF interface command on router RC. What is the status of router RC now? The status of this router RC we already verified. It's in backup designated router, right? We given the show command here in this RB. show IP OSPF neighbor, and here we can see 192.168.31.33. It's in BDR. Anyways, we will give this a show command, show IP OSPF interface in this router RC. Coming to this router RC, show IP OSPF interface, and here we can see the details, internet address, process ID, router ID, okay, and here we can see state BDR, backup designated router. Now step 8, turn off debugging. Enter the command and debug all on RA and RB to disable debugging. Okay, we will give that command and debug all. Coming to RA and debug all. Now coming to part 2, modify OSPF priority and force elections. Step 1, configure OSPF priorities on each router. To change the DR and BDR, use the IP OSPF priority command to configure the gigabit Ethernet 0/0 port of each router with the following OSPF interface priorities. For RA, we have to give it 200, for RB 100, and for RC 1. This is the default priority. And here they show this priority configuration for the router RA. Interface G0/0, then IP OSPF priority 200. So we can do that. We will go to RA. Conft, we will go to that interface G0/0, and we have to give IP OSPF priority 200. Next we will go to RB. Conft, interface G0/0, and we will set IP OSPF priority 100. Okay, right? Then coming to this RC, conft, we will go to the interface G0/0, IP OSPF priority 1. Step 2, force an election by resetting the OSPF process on the routers. Starting with the router RA, issue the clear IP OSPF process on each router to reset the OSPF process. Okay, we will do that. Coming to RA, and here we will give that command, clear IP OSPF process. So just we will give end, and here we can give clear IP OSPF process. So reset all OSPF processes, yes. Now we will go to RB, exit, and here we will give a clear IP OSPF process, yes. Then we will go to RC, end, clear IP OSPF process, yes. Coming to the last step, step 3, verify DR and BDR elections were successful. Wait long enough for OSPF to converge and for the DR BDR election to occur. This should take a few minutes. You can click fast forward time to speed up the process. Okay, so just we can give fast forward and we can verify this DR and BDR. According to the output from the show IP OSPF neighbor command on the routers, which router is now DR and which router is now BDR. They given a note, if the routers do not elect the correct DR and BDR after setting the OSPF priorities, try restarting packet tracer. Okay, we will identify this. So I will go to RC and let me give the show command. Show IP OSPF neighbor, and we can see 192.168.31.11 is the DR. That means RA is the DR now. Okay, and 192.168.31.22, 31.22, that is RB. RB is the BDR, so it's correct. Okay, that's great. So in this packet tracer activity, just we learned about the DR and BDR and how they elected. Here we can see its completion status. It shows 100%. Now, dear friends, if you get any doubt or if you like to give any suggestions, please comment below, or you can contact our team using our website. And also, if you like our video, give a thumb and share with all your friends. Stay tuned, and we will meet again with the next video. Thank you.